So the cathode will produce hydroxide ion, and it will eventually turn ammonia. It will produce ammonia, and manganese dioxide, it will react to keep the paste running with hydroxide ion. So this is the total cell reaction, you can see. So this is the total cell reaction for dry cell. Okay, so manganese dioxide here, it helps to produce hydroxide ion, and it keeps the cell running. So the next topic of our class is lead acid battery, that is lead storage cell. So in the picture you can see that multiple lead storage cells are connected in series. You can see that, and anode is negative, that is anode is negative and cathode is positive. So let's look at the details, that is details of lead storage cell. That is, anode is made of lead, cathode is made of lead oxide, and electrolyte is 38% solution of sulfuric acid. So this is the details of lead storage cell. Anode is made of lead, cathode is made of grade of lead with lead oxide, and electrolyte is 38% solution of sulfuric acid. And discharge and recharge of a lead acid battery. Let's look at the discharge process. First of all, at the oxidation half reaction, lead is turned into lead sulfate by giving 2 electrons. Okay, so lead turns into lead ion, and by giving 2 electrons, that is the reaction of anode half cell. And at the cathode half cell, the lead oxide, it accepts 2 electrons along with hydrogen ion and sulfate ion, and it turns into lead sulfate. That means lead, the valency of lead was here +4, and after accepting 2 electrons, the valency of lead has become +2, that is lead ion has been reduced. So this is the discharging process. And if we connect this into a power supply, the half cells just gets reversed. So the anode becomes cathode and the cathode becomes anode, and by this way recharging happens, and just the reactions are reversed. So the products become reactants and the reactants become products. So by this process, if we connect this into a power supply, the cells are being recharged, and again the cells have been replenished with the electrolytes and the necessary substances that are required to run the cell. So this is the recharging process at the bottom. So you can see that it's connected to a power supply, and the total discharging reactions are reversed. So this is the recharging cell. So next come to the point, that is lithium solid state battery. So lithium solid state battery, it has lithium ion, that is polymer electrolyte, and lithium is used as anode and manganese dioxide is used as cathode. You can see the structure here clearly. So this is the structure of lithium solid state battery. So let's read the description. That is, the batteries are functioned as transfer of lithium ions from anode to cathode, and lithium ion batteries are highly efficient, and it has low density of lithium and lightweight. Lithium ions are lithium metals are very lightweight, so they can be easily used in electrical devices which need very small amount of space and small amount of weight. So application, what is the application of lithium ion cell? That is used in portable devices, that is cell phone, wristwatch, or laptop computers. All the electronic devices nowadays are made of lithium ion batteries, and the another benefit is it's very much light in weight, and it can be used in aerospace technologies, that is in space shuttle or satellites, etc. So these are the major uses of lithium ion battery. So let's look at the cell reactions. The cell reaction, it takes place at the cathode. There cobalt oxide combines with lithium ions to form lithium cobalt oxide, and the half reaction is given here. So the cobalt oxide reacts with lithium to form lithium cobalt oxide, and this is the half reaction for cathode. and oxidation half reaction, the lithium carbide, that is lithium carbide, it turns into carbon and lithium ion with it forms it donates to it donates an electron. So there is the full reaction, that is lithium carbide and cobalt oxide, it forms carbon and lithium cobalt oxide. This is the full reaction. So this is the discharging reaction. So you just have to remember the reaction, and in the reaction is written in so many types in so many books. You can just follow one reaction, or you can just follow the reactions here. That's not an issue. Just you have to write the reactions properly. So that please keep in mind. And the charging reaction will be reverse. So let's look at the discharging reaction here, and let's look at the recharging reaction here. So you can clearly see that the reactions are just reverse. So carbon and lithium cobalt oxide, these were the products, and if we connect it to a AC or DC power source, the reaction will just get reverse, and the reactants will become products, and the products will become reactants. So this is the charging section, and this produces the reactants again, which is used as reactants in discharging process. So the recharging reaction just produces the reactants again. Okay, so this is the cell reaction. So the discharging and recharging process, it's just as the similar for rechargeable batteries like lead storage cell and lithium ion battery. So this is the it has just same similarities. So the next topic is fuel cell. Let's come to fuel cell. So fuel cell are such type of cell that is they are galvanic cells, and they produce hydrogen and oxygen, that is byproduct water. So they produce water, and they keep the environment safe, and they produce power as a product. So fuel cell, it uses hydrogen and oxygen as fuel, and at the end the byproduct is just water. So it keeps the environment clean and safe. So this is the structure of fuel cell. So at the left side we are seeing anode, and at the right side we are seeing cathode. So anode is positively charged, and anode is negatively charged, and cathode is positively charged. And at the end of anode, hydrogen gas is inserted from the inlet, and oxygen gas is inserted from the inlet of the cathode. And at the middle there is aqueous solution of potassium hydroxide, and the electrodes are made of porous carbon electrodes containing metallic catalyst. That means at the pores of both of the metals, the powder formed metals are inserted into the pores, so they act as catalyst. So this is the structure of fuel cell. So let's look at the description. So fuel cell differs from an ordinary battery that the reactants are supplied from external source. So they are supplied externally. Okay, so we can see in the picture that hydrogen is supplied from external source, and oxygen also supplied from external source. This is the main difference between a fuel cell and a standard galvanic cell. So fuel cell is used in space vehicles, and they are supplied from external storages, and here potassium hydroxide is used as electrolyte, and carbon rods are used as cathode and anode. So this is the main difference between fuel cell and all other rechargeable cells. And let's look at the reaction of fuel cells, that is the reaction of cathode and reaction of anode. So in cathode we are seeing that oxygen is reacting with water to produce hydroxide ion, and anode is reacting with the hydroxide ions to produce water. So overall reaction will produce water as byproduct, and at the completion of the reaction we'll get electricity from the specific cell So this is the reaction. Please look at the reaction that in cathode oxygen is supplied externally, and in anode hydrogen is supplied from external source, and overall reaction hydrogen and oxygen is making water. Such simple as that, and very much effective and environmental friendly. But the main problem of the fuel cell is that the cell is very much costly, and it's not for general use or common use. It's not being used in wide scale, so the setup cost of fuel cell are expensive. So it will take time to produce more and more fuel cells for our environment. So this is a problem. This is the end of our slide and end of our chapter. So the electrochemistry, the part which I was conducting, now it's the end. So if you have any questions regarding this, you can talk to me, or you can consult me in my YouTube channel, or you can also knock me in my Facebook, or you can if you have trouble contacting in Facebook, you can also contact me in my cell phone. So I wish that you will have good time in the upcoming Eid, and you will take care of yourself, and please stay home, stay safe, and if you go outside, please take care of yourself and take protective measures. So that's all for today. I hope you will be safe with the grace of Almighty. So that's all for now. Please take care. Allah Hafiz.